Okay guys, so we're going to go on to a second, a little more sophisticated approach to looking at the motion for this dot model and the battery powered car. I have a sample of like what the data would look like, and you can see I have the 0.0 second mark and I have the 0.1 second. So what we want to find out is how fast was it moving at this time? Now the problem with instantaneous speed, if you remember, is that you can't measure instantaneous speed, you can only approximate it, because what we need is for some time to pass. And so if I just ask you how fast was it moving here, I could of course take this time, 0.1 seconds, but that's not going to give me the speed here. That's going to give me the average speed for the first 0.1 seconds, and I don't care about the average speed. What I want to know is how fast was he moving at that point right there. So we're going to use this approach of approximating our answer. We're going to set up a little tiny window, a very small window of time, and we're going to say how far did the car travel during that small window. Now one thing that's really important is I want this little window of time to be, first of all, very small, but I also want it to be centered on this. Because essentially what I'm going to do is I'm going to use the average speed formula, but because I'm using that very small time window, it's going to give me a very good approximation of the instantaneous speed. Now we can get down to this window if I do it this way. So here's my time marker. I'm going to go 1 dot forward, I'm going to go 1 dot backwards. So that I'm going to refer to from here on forward as the 2 dot distance. The 2 dot distance is a very narrow distance of time and distance, and so what it's going to allow me to do is to get an approximate value for the instantaneous speed it's pretty accurate. Because our window, realize, is only 2 dots, that means that it's only 2/60ths of a second. That's a pretty small window. So I'm going to get the instantaneous speed. The way I'll get the instantaneous speed is by looking at that little window and taking the 2 dot distance. And since 2 dots always represents the same amount of time, I would simply divide by whatever it represents, and that would be 2/60ths of a second. So this is a very sophisticated technique. We're going to use what all devices that measure speed do. We're going to try and make the smallest window we can so we can get the most accurate measurement of how fast was this guy moving at this time. And we'll take a peek at every 1/10 of a second. We'll look at 0.2, 0.3, and 0.4, and we'll make the same measurement, and let's see, was the car really traveling with a constant speed? This is going to help us to figure out if that was really happening. So I have already marked your paper for you, and I'm going to switch sides here. Okay, let me just show real quickly what we have. So starting with our starting point over here at the 0, so I have gone 1 dot forward and 1 dot backwards so that I can see, I'll come over just a little bit this way, there you go. So that I can see the dot that is before the time marker and I can see the dot after the time marker. Now this might be surprising to you, but we can actually get the speed here at 0.0 seconds because remember, I didn't pick the first dot. I waited until I felt like the vehicle had gotten to a point where it was traveling at a constant speed, and then I put my 0 dot down. So there were 20 or 30 dots before this, and I'm going to take advantage of that to figure out the speed. So what you're going to be measuring is the distance from this dot over across the time interval to the other side and get that distance. So that's going to be 1, 2 dots, and you're going to always be doing that. If we go over to the next one, again, you'll see 1 dot back, 1 forward, that's 2 dots total, and we'll measure that. I will put my pen in there so that you can see, because when I put the ruler in, I'm going to cover up these little lines that are down at the bottom. And you're going to make the measurement. I'm going to help you with the first 2, and then I'm going to let you go ahead and do the rest of them on your own. So let me just really get this lined up well. Make sure I can get this as well as I can. Okay, so I feel like that's pretty good. And what I'm looking at is the distance between this dot and that guy right there. So I'm gonna help you out with the first one. When I look at this, it looks like it's between the marker that says 1 and the first line after the 1. So I would say it's pretty close to being right in the middle. And I would say that that is going to be 1.0, because I haven't gotten to the first mark here, 1.05. I'm gonna say it's right in the middle of that guy, so 1.05. Okay, let's take a look at the second one, and let's see if it's the same as the first one. If the vehicle is traveling at a constant speed, then we should see a pretty consistent distance there. Okay, so let me just get that lined up. All right, so here's the dot that I have the 0 lined up with. I'm going to go across the time marker to this dot. Now that looks very similar. I would say it's also between the marker that says 1 and that first line that comes after the 1, but I think that it's a little bit closer, slightly closer to this line. I'm going to say that's 1.06. Now, if you think it's 1.05 or 1.04, that's totally fine. That's your interpretation. Mine's not right. That's just what I can see from my angle right here. So I'm going to set up the ruler. We're going to pause for just a second so you can make the other 4 measurements. And I'll point at the dot so you can make sure that you're looking at the correct one. Okay, so going on to 0.2 seconds. Let me get this guy lined up. Okay, looks pretty good. And you're measuring that dot right there. I personally think that that dot looks, again, also maybe a little closer to that first line, but we'll let you guys make the measurement. So again, that's this dot right here, from the 0 to here. Okay, we'll move on to 0.3. Let me get this guy lined up really good, really well. Okay, so the 0 lined up, you're looking at that dot right there. That looks to me like almost on the 1.1 line. So you make your judgment. Is it on the 1.1 line or is it before it? If it's before the line, you're going to say 1.09 or 1.08. If you think it's right on the line, then you would say 1.10 would be your final measurement. Okay, on to 0.4. Let's get this guy lined up. All right, so again, got this guy lined up on the 0. This is the dot that we want to measure. So it's a little bit more than 1, but what do you think is the exact value? And on to 0.5. Okay, so here's the 0 dot is lined up with the 0 on the ruler. I'm looking at this one. It looks like it's in between that the 1 and the first line after the 1. You make your judgment what you think that value is. And one more. Last one at 0.6 seconds. Let me line this guy up. Okay, now I have to tell you, I notice a pretty significant difference in this one because it actually, the dot, so we're measuring from this dot to the one over here, and this dot actually is past 1.1. So now we might even be 1.2. I'm going to let you be the judge of that. Is it 1.20 or is it 1.1 something? You be the judge. Okay, so now you guys have all of your data. You already have the formula. You're going to take that 2 dot distance and divide by 2/60 of a second, and that's going to give you the speed for each one of these little time intervals. And then you can make your BT graph. And you'll be able to see, was this vehicle traveling at a constant velocity?